Hello everyone, today we are back with our next video, that is depression in freezing point. This is part 3 of solution. So today we shall learn depression in freezing point. So these are the formulas. I've written down 3 formulas which will be very important while solving the numericals from depression in freezing point. So the first formula we have out here is delta TF is equal to Kf into m, where m, small m, is the molality. Kf is a constant. Delta Tf is elevation at depression in freezing point. So previously we have done boiling point, where it is elevation in boiling point. Elevation means it is increasing, whereas depression means it is going lower, it is getting lower. And the next one we have delta Tf is equal to delta Tf is equal to Tf naught minus Tf, and also we have Mb is equal to Kf into 1000 into Wb, W divided by Wa into delta Tf. So in order to solve the numericals, we need to know all these formulas, these 3 formulas out here. So let us look at the terms. We have delta Tf is equal to depression in freezing point. So you need to know each and every terms. Delta Tf is depression in freezing point. M, small m, is the molality. Wb is weight of solute. Wa is weight of solvent. Mb is equal to molar mass of solute. Tf naught, freezing point of pure solvent, and Tf is equal to freezing point of solution. So the terms are somehow similar with the boiling point as well as vapor pressure. Wa, Wb, all these are similar. Previously in boiling point it was delta Tb, Kb, Tb naught, Tb. So out here in freezing point it is delta Tf, Kf, Tf naught and Tf. Just the B term is changing to F. So using this formula we shall solve the numericals. So let's start our first numerical. So let's start our first problem. Out here is the question. So first of all we shall write down the given again. 15.0 gram of an unknown material was dissolved in 450 gram of water. The resulting solution was found to freeze at minus 0.34 degrees Celsius. What is the molar mass of the material? Kf for water is equal to 1.86 Kelvin kg per mole. So this is the question out here, and we'll write down the given. So previously I have said whenever 2 grams are given, always remember the first one will be Wb and the second one will be Wa, because we dissolve a solute in a solvent and both are in grams, so they are the weight. So weight of solute, weight of solvent. So this will be Wb, this will be Wa. The resulting solution was found to freeze at minus 0.34 degrees Celsius. So that is the freezing point, and it is saying the resulting solution. So what do we have? Tf, that is minus 0.34 degree Celsius. What is the molar mass of the material? So we are supposed to calculate Mb. So here is the question mark. We have Kf is equal to 1.86. So these are basically the given from the questions. So if you look at the question out here, you will see that they have given freezing point of solution and they haven't mentioned freezing point of pure solvent, but we know that the solvent is water out here, and we should also know that freezing point of water is 0 degree Celsius. Freezing point of water is 0 degree Celsius. So these are the given that we can write from these equations. So now we shall start solving. So we have out here TF and TF naught. From this we can first of all find delta TF. Delta TF is TF naught minus TF. So we have delta TF is equal to TF minus 0.34 degrees Celsius. So we shall have plus 0.34 degrees Celsius. So delta TF is equal to 0.34 degrees Celsius. So now we have the formula MB is equal to KF into 1000 into WB WA into delta TF. So this is the formula we have. So what are we supposed to find? We are supposed to find the molar mass of the material, that is MB. So out here, this is the formula we shall use. So I'll just put all the values. We have KF is 1.86 into 1000 into WB is 15, WA is 450 into 0.34. So what I shall do is I shall remove all the points, do the cancellation, multiply and then divide in order to get the answer. So 186 into 1000 into 15, 450 into 34. So after the point we have 2 digits, so I'll put 2 zeros below. After the point we have 2 digits, I'll put 2 zeros above. So I can cancel these two. I can cancel these zeros. I can cancel with 5 as well. 5, 3. And then we can cancel this one. 3 1 is 3, 3 6 is 18, 3 2 is 6. I can cancel this one. 2 1 2 7 is 14, 2 3 is 6, 2 1 is 2, 31. So now I shall get 3100 divided by 17. So if we calculate these values, we shall have 182.3. If we calculate this value, we shall have 182.3 gram per mole. So this shall be our answer. So in this way, you can cancel all the values and then divide these two, or you can take log as well and then solve easily. So out here, I have written down the givens from this question. Calculate the mass of a compound. Molar mass equals to 256 gram per mole, to be dissolved in 75 gram of benzene to lower its freezing point by 0.48 Kelvin. Kf is equal to 1.2 Kelvin kg per mole. So if you look at the equation carefully, we shall first take out the given. So molar mass, according to this formula, we have only one molar mass, which is Mb. So this will be your Mb. Mb is equal to 256 gram per mole. So Mb is equal to 256 gram per mole. Then after that we have benzene to lower its freezing point. So previously I have said that depression in freezing point is lowering of freezing point. So lowering its freezing point by 0.48 Kelvin. So that means it is delta TF. So delta TF is 0.48 Kelvin. So out here we have delta TF 0.48 Kelvin. Kf is given. Kf is 5.12. So Kf is equal to 5.12. So calculate the mass of a compound that should be dissolved in 75 gram of benzene. So previously also I have said that we dissolve a solute in a solvent. So out here this becomes your solute. We are going to dissolve a solute in a solvent. So they are asking you what is the mass of the solute that should be dissolved in 75 gram of solvent. So this out here there is also a mass and there is also a mass out here. So this will be gram, this shall also be gram. So 2 grams will be given. The first one shall be WB, the second one shall be WA. After WB, they have given MB. So this is also B, this is also B. Always remember together they have given you. So you're going to calculate WB. So I have given question mark out here. WA is 75 gram. So now we shall write down the formulas. So here is our formula. So we are going to calculate WB. So I need to rearrange the formula. So here is the rearranged formula. WB is equal to MB into WA into delta TF divided by KF into 1000. So you're going to multiply all these values and divide by these two. So I'll write down the values. MB is 256, WA is 75 into delta TF is 0.48, KF is 5.12 and then 1000. So always remember it's better to remove the points. So after the point we have 2 digits out here, so I'll put 2 zeros above, and after the point I have 2 digits as well, so I'll put 2 zeros below. So I can cancel this one. So these are our values. So if you want, you can take log and solve the problem, or else you can easily calculate, multiply, cancel the values, multiply, and then divide the values in order to get the answer. So WB will be, so we shall get 1.8 gram. So if you multiply these values and multiply these values, and then if you divide, you shall have 1.8 gram. So this shall be our answer. So the weight of the solute should be 1.8 gram. I hope this simple multiplication and divide won't be a problem for you. So now we shall try our next problem again. Addition of 0.643 gram of a compound to 50 ml of benzene, density 0.879 gram per ml, lower the freezing point by 5.51 degrees Celsius to 5.03 degrees Celsius. If Kf for benzene is 5.12 Kelvin kg per mole, calculate the molar mass of the compound. So these is the equation. So first of all, we shall write down the given again. So this is the first gram we have, and out here this gram addition means adding. So we are adding this gram in this gram of benzene, but out here there is no gram, there is ml. So we need to convert this ml to gram. So first let me write WB out here. So WB is equal to 0.643 gram. So how do we convert an ml to gram? So we have volume is equal to mass by density. So using this formula we shall calculate. So out here our volume is 50 ml and density is 0.879. So how, if you multiply these two values, we shall get the mass. So our WA, so if we multiply these values, we shall get, so we have 43.95 gram. So that becomes our WA. So remember, if it is given in volume, you need to multiply with density in order to convert it into gram. So after adding these two, lowers the freezing point by 5.51 degrees Celsius to 5.03 degrees Celsius. So after adding these two compounds, previously the freezing point was 5.51 of benzene. So after adding these two, the freezing point reduces to 5.03. So we can write out here TF naught. So TF naught, previously it was 5.51 and then it reduced, after adding these two, it reduced to 5.03. And we have TF is equal to 5.03 degrees Celsius. So you may get a little bit confused out here, so I'll just help you with simple trick. So whenever 2 degrees Celsius is given, according to the formula we have delta TF is equal to TF naught minus TF. So TF naught shall be bigger than TF. So out here 5.51 is bigger, so I'm taking this one as TF naught, and the smaller one TF 5.03. Why? Because TF naught minus TF. So we are going to subtract a smaller number from a bigger number, and KF is given the compound. So out here we have delta TF is equal to TF naught minus TF. Why did I take TF naught? Why did I take this number as TF naught? Because the bigger number, the smaller number, we are going to subtract from the bigger number. So this shall be bigger, this shall be smaller. So TF naught we have 5.51 minus 5.03. Just a simple trick. Take the bigger number as TF naught and the smaller one as TF. So if you subtract these values, you shall have 0.48 degrees Celsius. So this becomes our delta TF. So now we have the formula MB is equal to 1000 into KF into WB WA into delta TF. So since we are going to calculate molar mass, so out here we have this one. So I'll just write the givens. 1000 into KF is 5.12, WB is 0.643, WA is 43.95 into delta TF is 0.48. So let me again remove all the new points out here. So I'll write 512 into 643, 43.95, 48. So after the point I have 1, 2, 3, 4. So I'll put 4 zeros above. And after the point I have 1, 2, 3, 4, 5. So I have 5 zeros below. So I'll just cancel all the zeros out here. So we have 100 into 512 multiplied by 643 divided by 4395 into 48. So let's put here MB, we have MB, we have MB. Taking log on both sides. So we have log MB is equal to log 100 minus log 100 plus log 512 plus log 643 minus log 4395 minus log 48. So if I put these values out here, log 100 is 2, log 512 is 2 point, log 643 is 2.8082, log 4395 is 3.6429, log 48 is 1.6812. So log MB we have, so you'll have 2.1933. So now we shall take MB is equal to ANTILOG 2.1933. So our MB shall be, if you take the ANTILOG of these values, so you'll have 1561. 1561. Since it is 2 points, so 2 plus 1 is 3, so you can put point after 3 digits. So this will gram per mole. So our value MB shall be 156.1 gram per mole. So this is how you can solve using log. If you use log, you just need to add and then subtract, take antilog, and you shall get the answer. You don't need to multiply and then divide. I hope you know how to use the log table. If you don't know, please check the I button and check the description. I have given the link in order to learn how to use log and antilog table. We shall now solve our last numerical. So out here is the question. The molar freezing point depression constant of benzene is 4.90 Kelvin kg per mole. Molar freezing point depression constant. So let me just write the given. That constant is Kf. So Kf is 4.90. So I'm not writing the unit right now. Selenium exists as a polymer of the type SEX when 3.26 gram of selenium is dissolved in 226 gram of benzene. So there are 2 grams again. The first one will be WB, which is 3.26 gram. The second one will be WA, which is 226 gram of benzene. The observed freezing point is 0.112 degrees Celsius lower than for pure benzene. So again out here there is a term lower. So again this will be what? This 112 degrees Celsius. Deduce the molecular formula of selenium. So you're going to write the molecular formula of selenium, and the atomic mass of selenium is 78.8 gram per mole. So out here, what is not given out here? We don't have MB. So first we shall calculate the molar mass of selenium, and then we shall calculate the molecular formula of selenium. So first we have MB is equal to 1000 into Kf into WB, and then you have WA into delta TF. So this becomes our formula out here. So I'll put all the values. 1000 into Kf is 4.90, and then WB is 3.26, WA is 226 into 0.112. So I'll just remove all the points. 490 into 326, 226 into 112. So after the point I have 1 2 3 4 4. Also I'll put 4 zeros below. After the point I have 1 2 3. I'll put 3 zeros above. I'll just cancel the zeros. And now I'll have 100 into 490 into 326 divided by 226 into 112. So if I calculate these values, I shall have, so you shall have 631 gram per mole. 631.0, so you can just take 631. So this shall be the molecular mass of selenium. So I can write out here molecular mass of selenium as just write SCX equal to X into atomic mass. This is how we shall calculate the formula. Molecular mass of selenium is 631 equals to X into atomic mass. So what was the atomic mass in the equation? Out here we have atomic mass is 78.8. So I'll write 78.8. So our X shall be 631 divided by 78.8. So if we divide these values, we shall have 8 out here. So the molecular formula of selenium SEX is equal to SE8. Since X is equal to 8 out here, so SE8. So this shall be our molecular formula of selenium. So this way you can calculate the molecular formula of selenium.